Hi, everyone, and welcome to our masterclass. It's great to have you with us today. My name is Isabella, marketing manager at Gradion. I'm in Munich right now, and Jan is joining us from our headquarters in Ho Chi Minh City. So there's about a 30-degree temperature difference between us. Must be nice, Jan. And we would also love to see where you're all joining from. So if you want, feel free to drop your location in the chat. Before we get started, we would like to know a little bit more about your main goals for the session. So I will ask 2-3 questions. Moment. So I hope you can see it. Okay. It's working. Hi, Michael from Aachen. So thank you very much. I will share the results so everyone can see it. Oh, next question. Hi, Volker from Berlin. I think you can choose more than one answer here because maybe it's not so easy to say. So, thank you. I'm going to share it. Jan, you can also see that, right?
Correct. I can see everything.
So it's a mix of everything. Very interesting. Thank you. And the last question before we start. Andy says it says that hosts in discussion cannot join the survey. Oh. Is that true? Everyone who's a discussion participant cannot join the survey? Thanks for letting me know. Oh, perfect. Thank you. I'm going to share it. So this is pretty clear. So awesome. Thank you so much. So before we start, oh, sorry, the sun is coming here right at me. Before we start, just the housekeeping rules. We're here for about an hour. Questions are welcome at any time. you can unmute yourself and speak up. You can write questions in the chat, and I will read them for Jan. And yeah, with that, I would hand things over to Jan. Jan, are you ready to get us started?
I hope so. Welcome everyone, and I'm super looking forward to talking about the Spec-Driven development with you today. Maybe shortly some words about my person. My name is Jan Moser. I work as a principal consultant at Gradion. I usually work in the field of enterprise architecture, technology strategy, and organization development. And most of this is in regulated. My specialty is the regulated environment like medtech, defense, aerospace, or finance. Today, I would like to give you some takeaways. Let me see if the technique works. Yes, it does. I would first give you a short introduction about, or a reminder about what is AI, how does an LLM work, and how does prompting basically work. These are like prerequisites that we then can go to the next point and understand what does vibe coding mean, what is the cool part, what is the not so cool part of vibe coding. And then I would also give you an introduction about spec-driven development, what it is, what it can do for you. I show you how that would look if we code like this, and I try to make a short demo where you can see how this process would work. I hope my Claude does not sabotage me with token limits or bad network, but we will see. So let's hope the demo gods are with me. Let's then start with an AI 101. So a very short excerpt. I mean, we have several kinds of artificial intelligence which we can use. This is also a reminder. I mean, a lot of the automation stuff, a lot of times when we nowadays use something which we are here with the generative AI, which we now all know, ChatGPT, Claude, DALL-E, and other tools that have in the later years become very popular. If your project, like your problem does maybe not even need that. I mean, you have also much easier models like computer vision or natural language processing models. So if you just need to transfer spoken language into speech, like audio speech, or audio speech into spoken language, or if you need a computer vision, if you want to detect how many objects do I see, or do I see a special amount of red strawberries, for instance, if you would use an agriculture use case, then you don't need a full LLM for this, because then you have specialized models. We will have or focus today at the generative AI, as we need creative answer generating and also problem solving. So we will look at how those generative AI applications then work. And that's something we need to see is LLM agents. Nowadays, everyone talks about agents and how they work, and this is a short overview over the elements what such an agent is. If you talk to Claude or ChatGPT, this is not the model. So you are talking to the model, but the model here is part of a whole ecosystem of tools. First of all, what you have is a prompt recipe. That means that these are instructions given how this model has to behave. This is usually abstracted from you. Usually you don't see that. There are tools, or there are, when you host your own model, you can set that yourself. It usually means do not give harmful or racist or sexist answers, be fair, be thorough, and so on. You can set as what it should perform. You can also optionally add a persona. You can say, add as an actor, add as a scientist, act as an expert in the field of. So this is basically setting the character of the LLM agent you're talking to. In the second part, you have the interface. This is basically where you enter your your questions and you get back your answers. This is your interaction point with the LLM agent. Because LLM agents basically work on a statistics basis, and they are not so good when it comes, for instance, at math. And because to fill that gap, there is something called tools. A tool is basically, as you would have in your real life, a tool, you say, look, if you need to cut a steak, take a knife. And then the knife would be a tool which you can use. And if you then get a question, hey, can you cut that steak for me? You would use the tool knife to cut the steak for you or the person that asked for that. Another point is knowledge, especially if you have a bigger base or code base. If we will see, you need information, and it is not just like what were you talking about. Basically, you need lots of documents. Maybe you have also internal regulations. You have generated product catalogs, and the knowledge in form of documents and stuff, they are here to help you. That's something that is called RAG, retrieval augmented generation. And what it does is basically it indices your documents, and based on what the knowledge is in these documents, it gives you specific answers tailored to your company, tailored to those specific documents. And last but not least, in these agents, often you have a short-term memory. This is basically when you talk with it, the conversation you have with it. It can also extend that. It can have all the conversations and then get like your preferences. It can extract from this more information. These are all optional. So in the easiest case, you have an LLM agent, which is the model application. You have the persona, respectively the system prompt, and you have your user prompt, the interaction point, how you can interact with this model. The thing is, if you talk to this model, that costs something. Because this model, it has, I mean, you talk in English in your natural language with the model. That means at some point, this model needs to convert that into a currency it can use. And that's the token. And a token is how to say, it's not a word or a character itself. It's something that is defined by the model. And the token are usually three quarters of a word. And mostly LLMs give you only an amount of token. You will see why this is important. Those tokens cost money. If you use an API version of the models, you pay for 1 million token, this and this amount of money. And if you have a paid plan, you get a token quota, which you can not exceed per hour, per day, or per month. We will see why this will be important if we come to the spec-driven development, because tokens are the currency. And if you basically exceed your quota, usually the current AI model providers, they make you pay for extra tokens. The next thing which we need to consider when we talk about AI models is basically the context window. The context window is the amount of information a model can keep in its working memory. If you have kids or you have a pet, you basically know that as soon as you talk to them, at some point they forgot the important information. And that's the same with the context window of an LLM. It has a certain limitation. That's where usually those context windows are quite big. I mean, they can range from 100,000 to 1 million token. The problem is if this context window is exceeded, the model starts to eliminate the layer. That's very simplified, but basically it forgets the earliest information and focuses on the last 1 million or 100,000 tokens. If you have a lot of conversational history and said, yeah, this is really nice, can you do this and this and this? And you give him contextual data, and at some point you had some formatting instructions at the beginning, because this come from a document, and you talk too long with it, and this context window gets too big. Basically, those instructions, they fall out of the memory. So it does not remember that they were formatting instructions, and that could lead that the next answer lacks the complete context and maybe gives you the correct content, but not correctly formatted. We also will see why this is important, because when we are do spec-driven development, that means we generate a lot of context, and that can become a problem if it's too large. Maybe important instructions will fall out and we lack context, and in the end, the output will not be as good as we want it to be. Are there any questions about this very, very rough overview over how LLMs work? What are core attributes of an LLM?
For now, there are
Okay.
no questions, nothing in the chat, so it's fine.
Okay, good. Then I come also a very rough overview about prompting. This will also be important if you want to understand what vibe coding and spec-driven development are. So prompting is basically how we talk to a model. We can do that in a very trivial way, and we can also get a very trivial answer. And if the problem is simple, then we get the correct answer. But when we have complex problems or complex tasks, what we try is we use something that is prompt engineer, called as prompt engineering, context engineering. And what do? We try by generating smart prompts, smart information that the model can support us as good as possible. And how do we do that? We usually try to be clear and specific. That means we tell the model, hey, act as a expert on databases, act as a policeman, act as a nurse or something. So you give the context, and you also try to formulate the problem as detailed as possible. And that sounds much easier as it is, because one of the biggest issue or a lot of software projects have is people are not able to create clear and specific stories or clear and specific requirement input. And that's something we need to learn. And this is also something we need to learn when we talk to LLMs. And this we are still developing those skills. And the next one, to give you the context, is another part. We try to tell the LLM even more specifically, hey, look, if you're using front-end tasks, use this framework in this version. For formatting, use this and this tool. For back-end, use this and this tool in this and this version. Do write unit tests, do create an API specification, and all that stuff. You try to give it context, like boundaries, because what you want is you want the intelligence of the LLM to help and assist you, but you give it a boundary, because you say, look, we don't want unspecified stuff to go into our code base. We have a special set of rules. We have contextual constraints. We have organizational constraints, like we're a Java company or we use Angular as a front end. So if it would come up with, hey, do this in C# or do this in Kotlin, that would maybe not be helpful. So we try to give it the context. What we also do is we set the format and the style. This is especially necessary if you want structured output. Let's say you have some data in CSV files and you have a template. So you say, look, this is the template, how it should work, and I want the output to be looking such and such, instead of just, hey, look, do whatever you want. And then you will get an output often in a very prose format. And especially if you do a machine, you say, okay, the output is then read by another machine. That would take a lot of overhead because I need the human nature of this text to be stripped away to only focus on the data. It can also, on the cost factor, as we saw before, tokens are expensive, like token of currency, and tokens are, depending on the model you use, quite expensive. And if you get, let's say, 7 pages of an answer, and 4 of those 7 pages are basically text, which is not useful, which is nice to know or gives some context, but it's basically not useful for your task. That would cost you a lot of money. So always try to set the format and the style. And last but not least, try, if it's more complex, try to give it some examples. Say, look, if according to the rules above, if you give me this context, I would expect this output. And if you do that, give it 2 or 3 examples. And after that, the model output can improve. The thing is, all of this is non-deterministic. There is also not, I mean, there's not a rule that you say, if you do A, then B always comes out. It's also to be reminded that if you change models, I mean, even within the same company, if you change from Claude Haiku to Claude Opus, the same prompt can not be as good as the one that worked for the smaller models, and vice versa. And if you start to jump from one provider to another, from OpenAI to Anthropic or to Google, there can be significant changes in quality and accuracy of your output. So make sure that you're aware of what model you're prompting from and what information you need out of your prompts. Let's have, how do we define that context? The context we want to give is, first of all, the instructions, the system prompt. As given, often that is defined by the model. If you have like something like Claude, where you can create projects, you can generate some general instruction set. For instance, you are a finance expert and you're knowing all the standards that are applicable in financial environments, or you're an expert on SAP or stuff like this, where you say, okay, in general, I want the model to impersonate as this and this persona. The second part is the user prompt. We saw that if you generate a good prompt, a good context, it's much easier to get, maybe not good. I mean, you still can get good context with a not very specific prompt, but that's then often a lucky shot. And what you try, especially if you go into an enterprise environment, you want to try that the same prompt gives you maybe not exactly the same, but basic or within some guardrails, creative solution. You have the tools. The tools can help you to generate the context. They can jump in where your model has gaps in its skills. There's also, you could use MCP servers to connect to third parties if they offer a service and interface for this. You have the state, that's a short-term memory. So if you can refer to, look, the document you just created, can you update this and this and this? So this is something that in the context will work. You have the long-term memory. That depends on the tool you're using, how this long-term memory works. You have also the retrieved context. That's basically if you have a Dropbox or a Google Drive or a OneDrive and your application allows that, it can take those documents. Also, if you have it in a local share and you basically can index it. So what it does, it creates a set of vectors out of this, which are easier and more token friendly to interpret in the LLM. And then basically it can generate, because the model itself is not trained on your company data, hopefully, and because you most probably would like it to answer as an employee of your company. It should have those information and the retrieved context and also the long-term memory where you can save certain information, can help you to customize your experience when you work in the context with the model. So if we look shortly at the prompt elements, we have the system prompt. We have the user prompt. In the system prompt, you give it a character. You say the model should act as or should do that and that and that always. You have the user prompt. That's the interactive context. Basically, that's where you ask your questions. That's where you discuss or dispute with the model. And in the end, you have the knowledge side. You have the knowledge context. You have static or retrieved information. That means that's training data if you would fine-tune the model, or you can have documents that you basically embedded or indexed, and you can refer to your company context. And the last one is the memory context. This is basically your actual discussion thread or the session state when it is a custom model or model application where you maybe can also keep more information about you, about the discussions you had. The elements of a good prompt, again, just keep the clear context, tell it how it should act, give the background. Also, for instance, if you say, look, you should do this and this and this, make sure that it's not like, hey, create me a game. I mean, I think no AAA game, or if you look at a big game, there was like, hey, can you make a adventure game with a knight in it? You have to give more context, and that's what you would have to do in the contextual background. This is also something that's very important for the spec-driven. We will see then this later. In the output format, you have to think about first, how do you want the output? Do you want a bullet point list? Do you want a JSON file, an XML? Do you want a CSV? That's completely up to how should the data processed be downstream. Tone and style, if you do create posts or texts, then you can also give it a tone and say, look, be formal, it's for a technical crowd. You can use tech words in it, or you can say, explain me this, as if you would explain it to a 7-year-old person. So then the tone of the output would be adapted. Check what it should do and make sure that you iterative clarify. You can say, look, if you're unsure, give me what you have, then ask a question based on my answer, refine what you have, or add the refined content. And by this, like you would do with a real person, it's a question answer game. You should get to the desired result. And last but not least, I think most of you have seen that that image. There is a concept called CISO, shit in, shit out. And that's very, very, very important if you work with data and LLMs, because if you have an unstructured, unorganized data structure, if you have a very unspecified context, you will not get, or you can get out something good, but it's just a lucky punch. And if you add agentic AI, what we will see, it just have more agents that can produce bad data. So make sure that you're always aware that when you refer to data or you prepare context, that it makes sense. And what I learned is, if it makes sense to you as a person, then often it is a good input. If you see, if you come and see your data, oh no, I know it's a bit messy, that also directly refers to the output quality of your AI generated output. Are there any questions about the prompting? If not, I would come to the coding part. So what is vibe coding. Vibe coding is basically when we said, or at some point someone said, hey, why should I write the code myself? Let me try to talk to an LLM because it was trained on a lot of coding documentation. Let me try and tell the LLM what I want to produce and see what the LLM produces as a code. So basically, you shift from the developer role to the project manager or requirements engineering or a PO role, where you basically go and say, hey, look, please do this and this and this for me. And because you have the assembled knowledge of a lot of Stack Overflow and other sources, the LLM then will create the code for you. So, and because writing code is quite a long process, that can significantly help you. If something doesn't work, usually in the vibe coding, you will see that we have these feedback loops that you tell him, hey, look, I tried it, I got this exception, or nowadays you have MCP servers where it directly could connect to the output and would see, hey, look, there is an error, and then try to refine the prompt and refine the output, and by this go to the level of software you want. So what are the aspects of it, or what are we doing? Usually we use natural language for this. We don't have to learn a programming language. So what we are doing is we write it in some form of English or another language. I heard lately Polish would be the best. So if you speak Polish, good luck. Try it in Polish, because apparently this is what works best with LLMs for structured output. The code is generated by the large language model. In this context, just make sure you send a lot of information or code to a third party. Make sure that your contextual and legal framework allows that. Otherwise, they are local. You can host your model locally on your machine or on a locally hosted server. But be aware, you send a lot of inside infos and stuff that basically is the core of your application to a third-party provider. So what we are doing is instead of saying, hey, you have to implement it like this and this, we focus on the behavioral part, something that we always wanted. I mean, that's like test-driven development came in here. We focus on the test, on the behavioral test. It gets red, we implement it until it gets green, and then start with the next one. And that's like the step even further. We just describe our features and then hope that the AI understands it properly and provides code that is up to our standards. The thing is, it lowers the entry, or it seems to lower the entry for non-experts. The problem usually starts if you vibe code something easy and not really performance optimized. That works quite well. But if, let's say, there's a complex ecosystem, you need to understand the whole set of requirements from a project, also from a technical perspective, because you need to formulate those properly to get an output that is also like equivalent to a professional developer's output. So, and that, I think most of you have seen memes like this, because if you don't do that properly, you get something like this. And just as last time I gave this talk, I was told, hey, we don't see what the problem is. The code here is already stated, which you should enter and should only have been sent to your phone number. And the thing is, if you do not necessarily understand code or basics of security, this would even maybe look fine. I mean, it looks like the other applications I see, but in the end here is quite a big security flaw, which eliminates this verification step. The second is people or bad developers just get more expensive, because that was even in 2020 a very, let's say, questionable form of writing software. in 2025, you use this AI prompt. It's a meme, so it's not necessarily working. The thing is, it's also questionable input, but here you burn tokens. And if you do that, if you call that, let's say 1 million times a day, that will result in a very expensive OpenAI cloud or system bill. The next one is, and I catch myself doing this, think and write code. Like before that, we had to think about we have to think about a problem and how do we solve it. And often we say, oh, okay, look, let me formulate or type this into my AI agent. Magic happens. I get out some stuff, and without further reading, I copy paste it, see if it runs, and if it runs, I'm happy. I have to be very disciplined with myself. I mean, there are maybe people that are more disciplined than I. But that is something that you see a lot, that you say, oh yeah, the LLM told me so I copy paste it, and then you have huge security flaws, or you have blocking code, non-performing code, which leads in the whole application system ecosystem then to maybe bigger problems. So make sure that we will see, I mean, just writing code automatically does not mean you can switch off your brain. And I always say, because there is the I in AI, does not mean your eye can switch off. And last but not least, the thing is, a lot of people do that, and you see gazillions of YouTube videos or LinkedIn people, 2 lines of code transfer 1 week of work. And what you do here is, like, this is so broad, no context. We saw the elements of a good prompt. There is no context. It's basically just do magic for me and hope that it works. And chances that this works out is really, really low, unless it's a really small project where the complexity is low and also the code base is not too big, because then maybe the LLM can help you in performing this task properly. And that leads to something that we see here, that the vibe coding per se has maybe not the best reputation, because they say, look, yes, you can deliver software fast. The question is, if you call it production grade, I mean, an enterprise, I mean, if you have stuff like this, that you would not maybe like to happen, that this happens in your application, because at some point, I mean, this is still an easy part. There are other parts where people really put their validation phases in for a KYC framework, and they were there in an unprotected file share, and people could see that. So they had driving license and documents like passports and ID cards, and they even had over the EXIF data, sometime the address or the coordinates where it was taken. So I know this person's passport identity, I know their address, and that gets really, really dangerous or really, really questionable. And if you, depending on where you are and what the incident is, it can also get very expensive if people start suing you. So how can we make that better? Well, there is something called spec-driven development. And in the spec-driven development methodology, what we do is we try to write a formal specification, and we create the specification first. It's basically, if you think about it, it's the normal way of creating software, because usually software serves a business purpose. And what you do is you think about your business purpose, you try to describe your product. That's usually in requirements engineering. And what we do is exactly, we create the same. We try to describe what should our product do. We give functional features. We define in the feature what should be the feature of such a software, and we give it some constraint. We tell it, hey, look, We are a Java company, so your backend must be Java. We use Angular as a front end, so please use Angular as the front end. We have a policy that the test coverage must be, there must be tests for front end and back end. It must be at least 80% coverage, otherwise it's not useful. We give it more context, for instance, that you say, hey, you must never share security relevant stuff, or if you have sensitive information, use a HashiCorp Vault or a Azure Key Vault or an Amazon KMS for this. We have a naming convention that our classes are like this and this stuff you would do in a team as well. You define that hopefully upfront, and then basically the people adhere to this when they write code. And that's the same thing what we're doing when we do spec-driven development, except in the end, we let the AI work out some of those aspects for us. Where our brain comes in is usually in the earlier phases, and we specify what we want and let then the AI do the heavy lifting in form, or the time-consuming lifting in form of creating the code. We will see the cool part is that the specs we write, they're human readable. These are markdown files. So in this context, human can be in the loop all the time. I mean, if you see you generate some mistake and you cannot fix it out of the box, then you can ask some senior engineer or senior requirements person and say, hey, look, is that really correct here? And they can help you with this. And that's nothing new. Spec-driven development is around there since the early 2000s. Comes a bit after the Agile Manifesto, but it's basically here for many years. The problem is usually it's like test-driven development. People do not like to write a lot of documentation before they start coding. And I think this is also a challenge as a spec-driven AI development person. If you come from the developer side, a lot of the fun has gone out because you write now specifications instead of code. How do we work with the structured input? So we need structured input for this. And if we want, that's what I said before, if you write code, your results can be lucky or not lucky. It works or does not work. And what we try with structured input is to let the AI be creative, but restricted by stuff like technology, like guardrails, which we give. And if we make it in a markdown format, which is basically human readable, you can ensure on one side that it's first sustainable and reproducible, or more reproducible, as if you just say, write me a Python game about a knight. And the other thing is humans can read it at all time. And what we are looking at today is something called a DSPI workflow. There are other names for this, but it basically always works in the same. When we use this AI-assisted coding, most of the tools at the moment adhere to this. It splits this development lifecycle in 4 phases. First is the discovery. That means we define the guardrails. We say, look, this is what we want. The goal of our software is this and this. And we have several guardrails which you need to consider. And when this is then done, it creates a specification out of this. It says, okay, look, to assume this, to adhere to this and this, we need these and these and these guardrails. And from those, we create a plan. And the plan is then, hey, look, to solve this problem, I need this data model, I need these APIs, I need to do these tasks, I need to set up this infrastructure, and so on. Basically, in the planning phase, we create the output, which is then ready to be implemented in the last phase. And we give a very, very detailed set of instructions to the model itself, which it then can execute. And by this, you can significantly increase, first of all, let's say the professional or the profession grade quality of your software. And on the other hand, you can create it reproducible. So mostly when I tried it once or twice with the same spec, you get something that is very near. And if you do refine those prompts that you say, hey, look, if you have code that is already there. Do not just change it on a lot of by a lot of degrees. Then it will also adhere to what you already written and just change stuff that in the spec has changed. Before we come to the demo, I would shortly like go to summarize again on this DSPI flow. So first we need to understand what we want, and that means we need to understand where our boundaries lie. We will see in the demo, I will use something called SpecKit from GitHub, and there it's called Constitution. And these are basically the global rules that are for our whole project valid. So you say, okay, we build application X and we use this and this technology, we use this and this communication pattern, and so on and so forth. In the next, we turn those information plus the feature description. We describe a feature into a specification. We said, okay, look, we try to say, okay, we need some business logic. How do our flows work? We become like specific and say, look, from A to B, it needs to do this and this and this and this. If we go to the planning phase, what it does is it basically creates these phases. It says, okay, to do what the specification tells me, I need to first set up a database, I need to set up a project, and so on. I need to create tasks where you basically break down. It's basically the same as if you would work with your human team. You create some product backlog items, you create features, epics, stories, and in the end tasks. And that's exactly the same what the AI here does. In the planning, creates these tasks, and in the end, the implementation takes these tasks and execute it against the constraints that also were set. Let's say, hey, for everything you integrate, you need a unit test and stuff like this. And if you then do that, a lot of the code is very good already, or in my experience is very good already from the beginning. But still review it, and that's also where you could change implementational details. Are there questions so far? If not, I call it some kind of demo. It's not a full-fledged demo. The thing is, you will see, we will walk through several steps of this process. I made some demo application, some demo specification for it. In the end, I'm not sure how the implementation takes a lot of time. So I tried it yesterday, and it takes almost over 1 hour because there's a lot of tasks, and even if I use my Claude with sub-agents, it takes quite some time to do. And this is something we will see when we come back, that there are some caveats when you do spec-driven development. And if we look at it, first, what we have to do is the following. We want to initiate the spec kit. So let me see, we have this one here. What we do is here we creating a project. This is from SpecKit itself. We say, okay, I want to use Claude for it. These are several of the current agentic development frameworks. The thing is, I use Claude because it's fast. If you need local, you can also do this locally with local models. If your governance does not allow this, or if you want to save tokens and spend more on hardware, here I would recommend you then to use the RU option here because that's RU code gives you via Olama also the possibility to use a local model. In this case, we use Claude. We say we are on a Mac. That's why we use this. And what it then does is basically it creates me this shell. And when we shortly look at this, and let me see where we are. now we are too big up, but basically what it creates is, I can show you this, it creates this Claude file, and it creates something here, which is, we have some memory and we have templates which it use. This is all done by the by this initiation of the spec kit. So what we will have to do, I have some demo specification for this. I can shortly show you this here. This is the one I did. Where do we have it? Specify, close here. In the memory, so I have to put it here. So what you can see is these are all the documents I generated. These are basically my requirements. Here, this is something I generated. Did it also with Claude Code. This is a flight tracker, so I want to track some flights. So what we do is we generate a lot of documents where we say, hey, how do we handle UX? How do we handle UI? What are our functional or non-functional requirements in this case, where we say, look, we have some performance things we want to have, and in the end, let's say we have a development practice text where we say, look, that's how our stuff should be structured. We want RESTful APIs. We want dependency injection. We want, here it's .NET for the backend, and for the front end, we use Angular here 17. Also here some information, how do we want our project to be structured? And if we do that, this is the constitution file I was speaking. This is basically the basic understanding what can be used or cannot be used. Now I will have to copy this shortly into, because if you take this, it takes a long time to generate, and we don't have the time for this. So now we should have the where is it? Sorry. Yeah, correct. So to the memory, copy this. Where did we put it? Here. Okay, what we see is I just copied everything in here, and then basically we can go back to our console and start Claude. No. Correct. You see that you don't see nothing because it's all in hidden folders, and we can now use our Claude. Say yes. And what you can now do, it can generate something, it's called slash commands when you install this properly. So what you see, it generates this spec kit once. And what we do is we start with spec kit specify. What this thing does is basically it takes the constitution and all the documents are made. It generates some folder structure for the features, and then it would basically tell me, oh, okay, look, I found in your constitution that you have several things, features that you want, and you say, okay, let's do the flight tracking. Which feature do you want to specify first? And that's what you're basically now doing. And you see there is some magic happens. I say yes. So sorry, that is also something. I mean, it's a good thing that it does that and always asking, but for the demo itself, it could be a bit boring. So what it does is now creating the branch, as it creates a branch on Git because it's GitHub, so it generates the this branch, and it creates then now some specifications which tell me, hey, what should we do? Let me, on the other hand, here, open the file while it's working. So this window was project. Okay. And this now takes some time. You see also this is quite token hungry. It's basically not, it's not a cheap operation. And this is already 3,000 tokens it takes. So depending on how complex your stuff is and how many features you have, this is really token hungry. Yes, and allow it for this session. And again, as you see, these are the tokens are really fast, but like these are lots of tokens that are generated. So make sure that your plan hosts that. So whenever you do that, it's not token friendly. And you also see that this is not like a short-term task. So it takes some time, which you will have to factor in. So you're not like all the LinkedIn people want to tell you become 100 times developer. Maybe in this time, realistically, what I learned is it's about that you are 2 to 3 times faster, or I am basically 2 or 3 times faster. So what you then do is we have now done our initial spec. We can have a look at this. How does that work? If we see now in our flight tracker, we have a Claude file, which is basically the Claude specific one. The idea comes from my WebStorm. We have the .specify, that's where the constitution and our information lives. The scripts and templates are basically generated by the spec kit itself, and we have the specs. That's the first one we said, flight tracking. It generates a spec MD file where it says, okay, based on what you want and your flight tracking, we generate some, they call it user stories. In my opinion, these are not user stories, but more of features, but it gives you a structured output. And what you can do is you can now go to your requirement engineer and tell your requirement engineer, hey, look, this is how we want to work together. And if we look the next, it generates some, let's say we don't create the check for the sake of the time. What we do is we create a plan. Usually you would do a checklist. What it then does is it basically in your checklist creates a lot of questions, and then for each question you can have a clarify session. So it will ask you for each requirement that is deemed unclear with it, hey, how should I proceed? And you can generate this and then ask, it gives you options how to solve a technical problem. And in the end, when this is done, it will record what you decided, like what was the question, what was your answer, what is the decided method to solve it, and that generates or modifies the requirements in a way that it fits your specification. Again, you see that takes some time to do so. We maybe let it shortly run. I will show you then in the end what this was generating. In the meantime, while it's running, let me see. Yes.
Yeah, we have one question in the chat.
Yes.
Dayani asks, so generating specs and all this work is something that rather requirements engineers do?
As a developer, no, yes and no. I think the collaboration is important. It is the functional requirements is something I would ask my domain experts and my my requirements engineers. But if you look at this here, basically the whole let me see the specify. If I look, is it here? Something not here. if I look at this and I look at this for instance the architectural principles, this is something you would generate as a tech person. I mean, say I want separation. I mean, separation concern good practice. We want API first, make it stateless. This is you're not coding more, you're writing those documents, and that's something you need to like or not like. Honestly, I'm also not the biggest fan of this. But I mean, that's part of my job, especially if you go into the higher levels of software architecture, enterprise architecture, all you do is a lot of document producing. But yes, you're shifting basically from the execution implementation style to the style where you say, okay, I now am more in the director role than in the execution role. That's correct, yes. While it is still doing the creation of the meaningful spec file is a challenge. And it looks easy because you write text in English or your language of choice. But it's something that's time consuming and needs to be practiced. I mean, if you do this, it takes you, I would say, the first 2-3 times you fail. And if you never did write a spec before, it takes you also quite some time. I would say yesterday I used Claude and stuff, but it takes me 1-2 hours to create the feature text properly with all the side things. You can do it with less context, but as we know, context is your friend on the way that what good results you get. On the other hand, it's your enemy, because the bigger your spec files grow, the more likely you run into issues. The problem is the context window. We saw that it starts to forget. And the problem is the performance decreases a lot after around 10%. After 70%, I would say it's mostly useless what you can take. If you have helper, there are approaches how you can do that. You can have Claude skills, sub-agents, you can small fragmented context as I did. That's why I made all these MD files, because it can then chooses when it's like a tool. I can say, okay, look, if I need information for security or for this, you can make small files for this. And what you also saw, it's not token friendly at all. So, I mean, I burned yesterday through, I think, $20 of a token, like easily, because especially if you have bigger complex files, that takes a lot. And if you come into the implementation phase with a bigger code base, that takes very fast, very lots of your token. So we can here say, okay, you see it can do here a lot. It generates all your specification. And if we go back, if you want to mitigate your not token friendliness, or your governance says, hey, look, we don't want to do that, and send all our information and stuff to a third party, you can also do that. If you use a local model, I tested it with a Qwen 3 coder and Destral 2 small on my MacBook, and that works, but you need to have the hardware for this. So if we go to the summary, what I learned is that is something that that works for me. That works not only for development, it was also for testing. I did the workshop last week with a company that's focused on testing. Also there we could use this spec-driven approach. Unless everyone wants to tell you have to have no clue about coding, domain, and so on, you need to have a lot of understanding, especially of your domain, of how to write specification and the code you generate. The other part is, if you update your stuff, don't update the code. And I know that's something I still have to learn. Update your spec file, let it regenerate the code, instead of just fixing something and then the code and the specifications start to go out. And next time you generate something, it could be overwritten. The process will also not make you a 10x employee, despite people want to tell you that. I think realistically, it's 2 to 3x. That's 2 to 3 people you can replace with one. That's still for small organization units or for small departments that can be, I mean, with 2 or 3 people, I can do the work of 5 to 10 people. It's not cheap. And yes, there are several tools to do that. Spec-CLI, GitHub Spec-Kit, Kiro is something from AWS. You can also use anti-gravity for this, but like my experience is, for me, the best was Claude Code or the Claude in this context. If you have some questions, please, you can either write me an email. This should give us, should lead you to a Google Calendar where you can book a session with me so that we can talk if you have further questions. Let's see shortly how well it works now. We need to also do this. As you see, it's still working. We have more files. It's, I mean, if you would be focused on it, but what you see now is like you have more of the information which it generates. Let's see how fast or where it is. Also, in consideration of the time, do we have questions so far?
I don't think so at the moment, but yeah, we're running out of time, but we could still use some minutes for questions. Michael says no question, but he says, thank you, really great insight of your experience. Thank you, Michael. So yeah, as Jan said, please feel free to book a slot. And we will sending over the slides and the recording if you want, also a quick feedback form. And yeah, that's it from our side. You will hear from us for the next masterclasses, and have a fantastic week, everyone. Thank you so much for joining us today. So
thank you. Have a good day.
yeah.
I will also add to the slides. Sorry, I will add to the slides a list of tools. I will also send you the input until the implementation. So what you can try, you can see all the steps it does, and a short instruction how I created that demonstration. So you can try it out yourself and do something that is like not maybe your production database that could get deleted or so.
That's cool. So a lot of people are saying thanks for a great webinar. Thanks a lot, Jan. So that you
Thank
know,
you.
everybody is happy.
Thank you so much.
Thank you. Bye, everyone.
Thank you. Bye-bye.